Hello and welcome back. Well, this video will be part B for graphing systems of equations. You can see I have the same goals down and the vocabulary, but I'm not going to show the vocabulary a second time. For our first example here, they want us to solve a system by graphing when the equation is in slope-intercept form. So we have slope-intercept form over here. And the first thing I'm going to do is graph the first one in blue here, and that's going to have a y-intercept of 14, so I'm going to start right at 14. Then it has a slope of -2, so I'm going to go down 2 over 1, and actually I'm going down 4 over 2. I'm going to draw my line. I'll do the second one in red, so this one has a y-intercept of 1, that's going to be about halfway between, and has a slope of 3/5, so up 3 would be about right here on the 4, and then over 5 would be halfway between the 4 and the 6. And that's good enough to draw my line. I don't really care where the rest of the dots are, because the solution is going to be right here where they cross. And the lines appear to intersect at the point, and that looks like 5, 4. So if you substitute 5 in for x and 4 in for y, it makes both equations true. Therefore, 5, 4 is the solution to the system. The next example is asking us to do the same thing, only it's given it to us in standard form. So I have another system over here. I'm going to do the top one in blue, but instead of rewriting the equation in the slope-intercept form, I'm going to calculate the slope and the intercept directly from this form. So the slope is going to be opposite of a, so a is -3, so that would be +3 over, so this was a, over the b value, which is 2. So the slope is 3 over 2. And the y-intercept, the b value, is going to be c, so that's going to be 12 over, this one is 2, the b value is 2, so 12 over 2 gives us a b value of 6. So I'll go up to 6, that's my first point, and apply a slope of 3 over 2, so 1, 2, 3 over 2 will be here, 1, 2, 3 down over 2, 1, 2, 3 down over 2, and I'm going to draw my line there. I'll do the next one in red, so the slope there is going to be the opposite of a is 6, so that would be -6, over b, which is -4, so negative over negative is positive, so I still end up with 3 over 2, but my b value is going to be the 8 over here, divided by the b value of -4, so that's going to give me a b of, or y-intercept of -2, so -2 is right here, but it has the same slope. So up 1, 2, 3 over 2, 1, 2, 3 over 2. And if I go down 1, 2, 3 over 2, you can see there that those lines are not going to cross. The lines have the same slope but different y-intercepts, so the lines are parallel. Since they do not intersect, the system has no solution. This is an inconsistent system. Okay, the next one wants us to write and solve a system by graphing. Doing this by hand, I don't really prefer to do this. I'd rather have technology, but we're going to go ahead and try it anyway. The most important part here is trying to get the equation written. We don't have to worry about the graphing because we can always use graphing technology later on. But it tells us something about the Olympics. The number of men and women participating in Winter Olympic Games has been steadily increasing in recent years. In the 19th Winter Olympics, there was this many men and this many women participating. But in the 22nd Olympics, there was 1660 men and 1121 women participating. Part A wants us to write and graph a system to describe the number of men and women participating if, now here's you got to be careful, X represents the number of Winter Olympics after the 22nd. So X is representing how many Olympics that are occurring after, and Y is the number of men or women, which means we have two equations, one for men and one for women. Okay, so in order to create the equations for men and women, we have to realize that we have a 19th Winter Olympic with 1389 men, so 1389. That's an ordered pair for the men. We have another ordered pair for the men, the 22nd Olympics, and the number of men was 1660, so 1660. So this one right here, these are the data for men. And then the data for women will be 19th Olympics and 787. That's an ordered pair. And the 22nd Olympics, and the number of women was 1121. So in order to create my equation, I need to find the slope and then the intercept. So for the women, the change in the y is going to be negative 334 over, and it looks like we've got a change here in x of 3, negative 3 actually. So the slope is 334 over 3. Over here, the change in the y for the men is 271, and that's negative 271, and the change in the years or number of Olympics is still negative 3. So that ends up giving you a positive 271 over 3. Now, since we're talking about the x value representing the number of Olympics since the 22nd data, which is right here and here, well, that is my y-intercept. So the equation for men will be y equals 271 over 3x plus they started at 1660 in the 22nd Olympics. So 1660 in the women, y equals, and then their slope, of course, was 334 over 3x plus, and then the number of women in the 22nd Olympics was 1121. So that starting amount in the 22nd Olympics is our y-intercept. Now we're going to want to go and graph that. Okay, so I'll do the equation for the men in blue, so the men is over here, and I'll do the equation for the women in red. Okay, so the men have a starting intercept of 1660. So 1660 looks like it's probably right around here and has a slope of, that should be 271 over 3. So over 3. Notice how these are going by 4s, 4, 8, 12. So if I go over 12, that means I move this over 4 times, which means I'm going to make this go over 4 times. So I'm going to try to plot a point up along this line right here. So over 4 times means I went up 4 times. So that's about 1080. And that would put me probably around this point right here. So there's one graph. And our second graph is going to begin at 1121, which appears to be right around here. And I'm going to try to plot a point underneath this going over 4 times. If I go over 4 times, though, I'm going up about 1,300 or so from that point, which would put me right around here. And I draw my line through that. And it looks like they cross somewhere right about here. And if I look straight down, you can see that would be 24 Olympics, Winter Olympics after the 22nd. They want to know when the number of men and women participating will be the same, which Winter Olympics. Well, if it's 24 after the 22nd plus 24 would put us at 46. So to be right around the 46 Olympics, Winter Olympics. Okay, for our next example, they want us to use a system to solve a linear equation. Notice that this only has one variable in it, it's x. So if I treat this as a system, the only variable or the only information I care about is the x coordinate. There's actually 2 ways you can do this. You can treat this side as one equation, so call it y equals negative 6x plus 8. Graph that, and at the same time, graph this one when it's equal to y, so y is equal to negative 4. So I graph these two, and they'll have an ordered pair where they cross, but only the x value that goes here is the answer that I care about. The other option is to rewrite this problem so that it's equal to 0. So to do that, I would add 4 to both sides. So I'll end up with negative 6x plus 12 equals 0. And then I will just replace the 0 with y, and I will graph this. Okay, so here we have the first two graphed, where the left side and the right-hand side were set equal to y by themselves. And if you look at where they cross at 2, negative 4. But again, we don't care about the negative 4 because the y was not in the problem originally, so I only care about the x. So the x coordinate is 2, suggesting that that is the solution of the original problem. Now, if I put that other equation in, which was y is equal to, and that had a negative 6x, but that was plus 12, so plus 12, and then I look to see where it crosses the x-axis, you'll see it crosses at 2, 0, giving me exactly the same x-coordinate of 2 as the other system did. So there's more than one way you can actually solve these on a graph. Okay, so for this last one, we're going to solve a system again, but using graphing technology, and you can see why we'd want to do that. We have crazy decimals here and here and here and here. Now, since this is an actual system, it has an x and a y in the problem originally, I am actually looking for the x and the y ordered pair where they cross. Okay, so here we have it in Desmos, the first equation, the second equation, and you can see where they cross right here. That's not a very pretty solution. So most of the time they'll ask us to estimate that to the nearest tenth. So if we were doing this to the nearest tenth, we might say negative 5.5, comma, and then 2.5, and just leave it like that. But this is a more precise answer there. But you can see how difficult that would be to figure out if you were trying to graph this by hand.